Hey guys, today I'll be solving lead code number 973, clay closest points to the origin. Uh, the question itself is relatively straightforward. All we have to do is just gather the distance and figure out whether the point is close enough to the origin being 0, 0. If you've taken a high school geometry class, then you know that the distance formula is actually just x, whatever x you want to take, either of those positions, and then uh, y, and then just square it. This is the exact formula. So just calculate the differences between the x component, the y component, and that's it. That's your distance. The main thing about this question is using your heap. I already talked about heap before, but if I had to explain it in a nutshell, it's just there's two types: min heap and max heap. So min heap, the way min heap works is you will have your smallest element at the top. So if you have 3, you have 2, then the one at the root will be 1. If you have a max heap, it will be the opposite. So your biggest one would be at the root and your smallest one would be at the leaf. So when you do your pops, you get your maximum value when you have a max heap, and you get your minimum value when you have a min heap. So how do we figure this one out? All we have to do for this one is we will have our heap. So you can call it anything. I'll call it my heap over here. And we loop through the points. We will gather the distances, obviously. Just call the math.sqrt and then paste in the formula. So x minus 0, because we have to do it for, well, to the origin. So just take the zeros as is. You don't need to initialize anything else. And just do 2, square root that. That's your distance. Now the trick to this question is, if you shove every element inside your min heap and then you pop for k range, uh, your algorithm would actually be n log n, but what you want is n log k. So how do we do n log k? That is a bit more quicker than n log n, because n log n you would have to insert every single value of your points. N log k would mean, well, the height would be bounded to the k itself, right? So how do we figure that out? So do we want to pop off our top when we get out of the size? Yeah, we do. But do we want to keep it a minimum heap or a maximum heap? How do we determine that? Uh, in this question, we would like to do a max heap, because when we do pop off the root, we want it to be the one that's farthest away. We want to keep the ones that are the closest inside our heap, right? So that we can return later. So when the size gets exceeded, we will pop off our root and we will maintain a max heap, because so that the root that's being popped off is the one that's the farthest away. So in this case, essentially, if I use this as an example, if we had a distance 3, right, the same exact thing, distance 3 to 1, and we had k equals to 2, we see that, okay, we are already above the number of elements we should be having, and we have to pop off something. So obviously we don't want to pop off 1, right, because 1 is the best answer. So we would pop off 3, and that's why we kind of need a max heap. So the best way to just make a simple max heap in Python is, well, in any other language, is just putting it as a negative. So if you just do negative and then you push in your distance, it will be sorted by distance, and then you can keep your point over here. I forgot to do this over here, xy equals to point. Just do that so that you can use your x and y over here. But yeah, just push this in, so it would look something like, so for 0 and 2 it would just be -2 and 0 and 2. That's what the heap would look like. And now the key is, if our length is like we go over our length, you can do it with the if, you can do it with the while. I just prefer while. While then my heap goes above our k, that means we have more than k elements in our heap. We want to remove the extras, so heap q dot heap pop from our heap, so that we pop out the maximum element and we keep our smallest ones. At the end, just return a simple list comprehension. Just do point for d and point in my heap, because that's how you put it into the heap itself. And that's it for this question. That's all the code you need over here. Keep a max heap, pop it off when you exceed k, so that you end up running it in O log k time.